Greetings. My name is Robert Kale. I'm from Purdue University and I'm the lead author on an article entitled Longitudinal Evidence Linking Processing Speed to the Development of Reasoning. My co-authors are Arne Lervig from the University of Oslo and Charles Hume from University College London. In this video, I would like to introduce you to the research that we report in our article. Our aim in the research we report was to examine the cognitive consequences of age-related change in speed of information processing. Specifically, there's much research documenting that processing speed increases substantially during childhood, reaching adult-like speeds in mid-adolescence. In addition, other work links these age-related changes in processing speed to growth of more complex cognitive processes. Now, some evidence links increased processing speed directly with improved cognition. For example, age-related increases in speed are associated with greater scores on measures of reasoning and problem solving. Other evidence links increased processing speed to improved cognition indirectly via increases in working memory. In other words, increases in processing speed are thought to increase the capacity of working memory, which in turn facilitates performance on complex cognitive tasks. Now, nearly all the evidence linking increased processing speed to cognitive development, either directly or indirectly, comes from cross-sectional work. The goal of our research was to use longitudinal evidence to assess the direct and indirect effects of age-related increases in processing speed. Consequently, as shown in the slide, we assessed children's and adolescents' processing speed, their working memory, and their reasoning multiple times over 2.5 years. This design allowed us to determine whether increases in speed are linked directly to improved reasoning, indirectly via increases in working memory, or both directly and indirectly. Our sample included 277 children and adolescents ranging in age from 6 to 13 years when we tested them first. We measured processing speed with items like those on the visual matching and cross-out tasks from the Woodcock-Johnson battery, shown here. In both tasks, participants must compare visual stimuli quickly. We measured working memory with tasks in which participants had to remember information briefly while performing other cognitive tasks. For example, in the operation span tasks, participants answered simple arithmetic problems, then they later recalled the answers to those problems. Finally, we measured children's reasoning by asking them to complete problems taken from Raven's progressive matrices in which participants must select the item that completes a pattern. Well, our preliminary analyses showed the expected pattern of age-related improvements on all measures. In addition, scores on all three kinds of tasks were related positively. In other words, faster processing speed was associated with greater working memory and with more accurate performance on the reasoning task. But our crucial analyses tested longitudinal relationships between processing speed, working memory, and reasoning. We examined these with two overlapping sets of data, but for simplicity in this video, I'll just describe one set. This includes data from times 1, 2, and 4. We began with a full model in which all three constructs, speed, memory, and reasoning, at time 1 predicted the other two constructs at time 2. In addition, all three constructs at time 2 predicted reasoning at time 4. That model fit the data well, but the data were fit equally well with the simpler model, shown here, that included direct links from speed to reasoning at times 1 and 2, as well as at times 2 and 4. Working memory at time 1 was linked to reasoning at time 2, but working memory at time 2 did not predict reasoning at time 4. The findings from analyses of data from times 1, 3, and 4 were more complicated. I'm not going to try to describe them here, but I'll let you read about them in the article. I'll simply summarize those findings by noting that collectively they provide strong evidence for direct links between processing speed and reasoning, but much weaker evidence for indirect links via working memory. Thanks for watching this video. Arne, Charles, and I hope that you find the article useful and stimulating.